Here's another example. Looking at this function, we have three sections of the function. We have two vertical asymptotes, one horizontal asymptote, and we have some other points of interest, and we'll list all of these here. So let's look at the vertical asymptotes first. I see a vertical asymptote here of x equals positive 3 and one here, x equals negative 3. So we have two. X equals negative 3, x equals positive 3. We have one horizontal asymptote at y equals negative 2, so y equals negative 2. We don't have any oblique asymptotes. We do or do not have holes. I do not see any holes, so none. We do have intercepts. We have two x-intercepts. Appears to be at negative 2 and positive 2, so our intercepts negative 2, 0, and positive 2, 0. And we do have a y-intercept, and that appears to be at negative 1. So we also have 0, negative 1. Now that's on the curve in that middle section, and that's also going to be a value of interest to us when we read the range. But let's read the domain first. So the domain, as I read from left to right, I have two excluded values, both of those vertical asymptotes. So again, in interval notation, from negative infinity to the first vertical asymptote, jump over that with the union symbol and open up another interval, and then go to the next vertical asymptote. So I have negative infinity to negative 3, union negative 3 to 3, jump over 3 with another union symbol, and then we can go to infinity. So that's how we document the excluded values in interval notation. Now the range, as I read from bottom to top, well, I have an excluded value in the range, and that is y equals negative 2, because that's a horizontal asymptote. And then I also have something else happening. Notice when I look at the left section and the right section, they are approaching that vertical asymptote, or excuse me, horizontal asymptote from below, and they are limited by that horizontal asymptote. But when I get above the horizontal asymptote, the y-intercept happens to be the lowest value of y that's above that horizontal asymptote. So we have to be very careful that we have two pieces of the range. So the first is from negative infinity to negative 2. So that's showing that I have y values from negative infinity to negative 2, which is that horizontal asymptote of negative 2. And then I'm jumping over all of the values between negative 2 and negative 1. But I'm going to use a bracket here for negative 1 because negative 1 is on the curve. And then it looks like I go on forever to infinity. Now let's write all of the behavior near the vertical asymptotes and the end behavior. So we'll go through this a little quicker now. As x approaches negative 3 from the left, y is approaching negative infinity. So we say f of x approaches negative infinity. As x approaches negative 3 from the right, f of x is approaching positive infinity. So look at the graph to confirm that that makes sense to you. As x approaches positive 3 from the left, f of x is approaching positive infinity. As x approaches positive 3 from the right, f of x is approaching negative infinity. Again, look back at the graph and make sure both of those statements make sense to you. Now our end behavior. As x approaches negative infinity, y is approaching negative 2. That's our horizontal asymptote. As x approaches positive infinity, f of x is also approaching negative 2 on the right. So Again, look at those two statements and look at the graph provided and make sure you understand why.